linear equation in two variables. Has three forms. The first one is called the standard form. And we use the standard form to define linear equations in two variables. It looks like this. ax plus by, a times x plus b times y equals c. X and y are the two variables. A, B, C are constants. A is the coefficient of x. B is the coefficient of y. C is a constant. A and B are not both zeros, but one of them is zero, the other is non-zero, is totally fine. Yeah, we have seen something like this, x equals 2 or y equals 95. Yeah, those are also linear equations in two variables. They just represent something special, some straight line very special. If the equation missing variable y, it is a vertical straight line. If the equation missing variable x, it is a horizontal straight line. So this is the first form, standard form. We use the standard form to define linear equation in two variables. The second form is called slope-intercept form. It looks like this. Y equals mx plus b. X and y are the two variables. M, the coefficient of x, is the slope of the line, rise over run. And 0, b is the y-intercept. As a warm-up, because it's been a while since we work on straight lines, right? As a warm-up, we go over those concepts before we look at the new questions. And that's a slope-intercept form. In the slope-intercept form of the straight line, variable y is isolated on the left side. Everything else is on the right side. Two terms. A number times the variable term, and a constant term. The coefficient of the variable term happens to be the slope of the line. And the constant term is the y value of the y-intercept of the straight line. So that's slope-intercept form, very common use. Slope-intercept form involves slope, so the form only works for non-vertical straight line. That's why we cannot use slope-intercept form to define straight lines. And the third form is called a point slope form. It looks like this. Y minus y sub 1 equals m times parentheses x minus x sub 1. In this equation, x and y are the two variables. x1, y1, they are constants, and they are the coordinates of a given point on the line. Is a point on the line, and m is the slope. We don't use point slope form much. We use slope-intercept form the most of the times. Linear equations in two variables represent a straight lines. If you see equations in one of the three forms, you know you are looking at a straight line in a rectangular coordinate system. All right, so in last class, we learned a theorem involving two straight lines, parallel and perpendicular. Yeah, let's go over the content for the theorem because we're going to use the theorem for the next question on the worksheet. It's about parallel and perpendicular right here. If we have two straight lines, L1 and L2, they are parallel, then the two straight lines must have the same slopes. Vice versa, if two straight lines have the same slopes, then they are parallel. And another conclusion is about perpendicular. Two straight lines are perpendicular means they cross, and the angle formed by the two straight lines is 90 degrees, is right angle. So if two straight lines are perpendicular, then their slopes must be opposite reciprocal of each other. Yeah, what is opposite reciprocal? We studied that through question number 13. Opposite reciprocal. If the two slopes multiply to -1, then the two slopes are opposite reciprocal. Then their corresponding straight lines are perpendicular. So that's something we're going to use for the next question on the worksheet. We finished question 18 last class. So we are going to go over the first question, number 18. We're going to look at number 2, the second question, number 18. Let me erase those. Let's read the question. Find the equilibrium of a line in the slope-intercept form that passes through a given point 93,6 and perpendicular to x plus 3y equals 21. Okay, let's take time to solve this problem. Our target here, our goal here is to find the equilibrium of a straight line and in the slope-intercept form. Okay, yeah, we are going to find line L. Let L be the line we are looking for. Okay, and we are looking for the slope-intercept form of L. Slope-intercept form formula: y equals mx plus b. We need to know the slope. We need to know the y-intercept. Let's see, how do we find the two parameters in the equation? Let's see what information we have. We are given two pieces of information. The first piece, the line L passing through 93,6. That is given. And another piece of information is the line L is perpendicular to a given straight line, x plus 3y equals 21. When it comes to parallel or perpendicular, and those are about slopes, right? Yeah, parallel, if two lines are parallel, they have the same slopes. If two lines are perpendicular, then their slopes multiply to 91. Parallel and perpendicular directly related to slopes. So I'm going to start from the second piece of information, perpendicular, and then see if we can find a slope for the given straight line L, for the straight line L we're looking for. All right, since L, the line we're looking for, is perpendicular with the given straight line, the equation is given x plus 3y equals 21. Since line L is perpendicular with x plus 3y equals 21, the slope of L and the slope of x plus 3y equals 21. So the two slopes must be, do you remember the concept? Opposite reciprocal of each other. Okay? Yeah. So the given straight line is x plus 3y equals 21. Let's see what's the slope of the straight line. The slope of this straight line, x plus 3y equals 21 equals, let's figure that out first. In the given straight line, x plus 3y equals 21. Yeah, anyone can help me to find the slope for that straight line? That straight line is given in the standard form, by the way. Standard form. Standard form, a times x plus b times y equals c. We we learned two methods to find the slopes for equations if the equations are in the standard form. One method, my method, because it's very fast, once you grasp the method, is use the formula slope equals negative a over b. That's one method. The other method is you rewrite the equation in a slope-intercept form and then identify the slope. Okay, I give you 1 minute and let me know what's the slope of x plus 3y equals 21. I'm going to explain both methods after. This question is a little bit longer process. How do we find the slope of a line given in the standard form? In this case, it's x plus 3y equals 21. Feel free to share your answer. The equation is x plus 3y equals 21, right? And how do we find the slope? One method is to rewrite the equation in the slope-intercept form. And we are going to solve the equation for y. Because in the slope-intercept form, variable y is isolated on the left side. Then we should have 3y equals negative x plus 21. What happened here is I moved the term x from the left side to the right side. So the sign flipped. It was positive on the left side and it became negative on the right side. And then I'm dividing. You must have the slope already, right? You divide it by negative 1/3. Yeah. I missed the roll call, but okay, I saw you, Tevin. I'll remember to mark your present later after the class. Exactly, Amanda. Thank you for your answer. It's a negative 1/3. So we divide by 3. The coefficient of x, the green part, the coefficient of x is -1, right? So if we divide the coefficient -1 by 3, the coefficient will become -1/3. And here is also divided by 3. So we have y equals -1/3, -1/3 x plus 7. So the slope of the given straight line, x plus 3y equals 21, equals -1/3. Okay, we can get this done by using my method as well. Let me show you my method, the formula method. If the line is in the standard form, in this case, x plus 3y equals 21, ax plus by equals c. We identify coefficient of x is 1, coefficient of y is 3, right? And the quotient of a and b is 1/3. And take the opposite, we have a -1/3. A very fast way, very quick way. Anyway, the slope is found for the given straight line. And our goal here is to find the slope of L. We need to find the slope of L. Since slope of L and -1/3 are opposite reciprocal of each other, anyone can tell me slope of x is -1/3. So the slope of L should be equal to what? Knowing line L and x plus 3y equals 21, I kind of highlight. So the given straight line is the green one. the L is the one, the line we're looking for. L and the green are perpendicular. Sorry, L and the green are perpendicular. So the slope of L and the slope of the green, which is -1/3, should be opposite reciprocal of each other. Then what's the slope of L? My question here is, what's the opposite reciprocal of -1/3? What's the opposite reciprocal? Yeah, exactly. Thank you, Jacob. It's 3. Yeah, 3/1 or just 3. Exactly. And you should always double check. How do we double check? We multiply the two slopes together. One is 3, the other is -1/3. They do multiply to -1. They multiply to -1 means the two straight lines are perpendicular. All right. So now we have the slope of L. Now we have the slope of L. M equals 3. We still need to find a B in order to find the equation in the slope-intercept form. How do we find the value B? We're going to use another piece of information in the question, the given point, 93,6. Since 93,6 is on the straight line L, x equals 93, y equals 6. This pair would satisfy the equation y equals 3x plus b. Okay? L has slope 3, so we can write the slope-intercept form of L as y equals 3x plus b. B is unknown. B is unknown. Since 93,6 is a solution, is a point on the line, 93,6 is the solution of the equation. Since it's the solution of the equation, x equals 93, y equals 6 would satisfy the equation. So let's plug it in. If we plug in, we should have a true statement, right? Then we have, if we plug in y equals 3 times x plus b. Y is 6. Y is 6 equals 3 times x. X is 93 plus b. So I have 6 equals 3 times 93, 99 plus b. And solve b. Help me to solve the equation for b. What's the value of b? Which value minus 9 gives us 6? Or we can move the -9 over, right? What's the value of b? 15. Let's see. Awesome. Correct. Very good. It is 15. We found the value of b as well. So we got an equation. Therefore, the slope-intercept form of L is y equals 3x plus 15. And that's the solution of this question. The solution of this question has two parts. The first part is to find the slope. The second part is to find the b. We have two parameters in the slope-intercept form, y equals mx plus b. In order to confirm the equation, we have to know the values for m and b. So the first part is to find the value for m. Second part is to find the value for b. To find the value for m, we use the information that L and the green equation are perpendicular, right? Here. To find the b, we use the given point. The given point is on the line, so the pair is a solution of the equation. If we plug it in, we would have a true statement. And we set up the equation. The equation only has b as unknown. We can solve the equation for b to find the value of b. And then we have the slope-intercept form. You can watch the video from last class before the spring break. the process solving the first question is very similar with the process we just used to solve the second question. The only difference is number one, parallel. The line we're looking for is parallel to the given straight line. The second question is the line we're looking for is perpendicular to the given straight line. The slope part is different. Everything else is the same. And the third question, I labeled that as 19, is also a very typical. Oh, hold on, sorry. Any questions about this problem? It's very typical. Any algebra book would have something like that. Any algebra book involving straight lines would have problems like that. Very classical problems. You would have to know how to solve it. This is one way to solve it. Do you guys have any questions? Nope. Then we continue. Number 19 is also a typical or classical question in this chapter. Let's see what are we looking for in this question. We need to find the equation of a straight line that passes through two given points. We also need to write the equation in the slope-intercept form. All right, that's the question number 19. That's the requirement. Let's analyze the question. We know two different points determine a straight line, right? What we can do with the two given points? What we can do with the two given points? What we have done in the previous questions, or what we have found in previous questions with two given points. Do you remember? With two different points of the line, we are able to find the what? The slope of the line, right? Okay, so to find the slope of the line, we can use the formula. Slope equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. We can use the formula. That's the algebraic method. Or we can use the graphical method. Let me use the graphical method. Both methods have their pros and cons. I'd like you to try both and then to see which one you are able to handle. Okay, yeah, I'm going to use the graphing method first, because the reason I use the method because the coordinates of the 2 points are very are integers, easy to graph. I'm going to draw a rectangular coordinate system. And I'm going to plot the two given points in the rectangular coordinate system. The first point is -2, 5. Let me label 1, 2, 3, 4, 5. That's 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. And the other point is in quadrant 1, 1, 2, 3, 4, 5, 6. All right, one point is -2, 5 in quadrant 2. From the origin, we go to the left 2 units and go up 5 units. And it should be here. -2, 5. I'll label this point as A. The second point, 3, 4 is in quadrant 1. 1, 2, 3. From the origin, we go to the right 3 units, and then we go up 4 units. It's going to be, I'm going to adjust this. Two, 3, 3, 4. 3 units to the right, 4 units above is right here. Pretty small, right? Hold on. 3, 4. Let me move to the right a little bit. Yeah, that's the disadvantage of this method. You would have to draw a good picture, good graph, in order to apply this method. Okay, this is point B. I'm going to connect the 2 points. And I'm going to make a triangle, right angle triangle. Right angle triangle. From the right angle triangle, we can see the rise and the run. We're going to look at the picture, this graph from A to B. From A to B, let's figure out what is the rise, what is the run, and then we find what's the slope. From A to B, the rise, because from A to B we go down, right? We look at the graph from the left to the right. So from A to B, the line goes down. The line segment goes down. How many units down? 1 unit down. Only 1 unit down. So the rise is -1. The rise is -1. From A to B, the run is going to be positive. How many positive? How many units positive? This is -2, right? Yeah, my picture is not very accurate. This is -2, and this is 3. How many units to the right from A to B? 5. Awesome. Exactly. Thank you, Jacob. 5. So run equals 5. Run equals 5. And slope equals rise over run. We have a -1/5. That's the slope. That's one way to find the slope by using the graphical method. What if we use the algebraic method? Let me show you the algebraic method, okay? I'm going to write one point on top, the other on the bottom. It doesn't matter which one on the top, which one on the bottom. But you need to keep the consistency. If you write 92,5 on the top, 3,4 on the bottom, you would have to keep that way the entire time. And slope equals changing y over changing x. So we're going to have, remember, parentheses minus parentheses, all over parentheses minus parentheses. Remember that? In the numerator, we are going to put this in the first parentheses and then put this in the second parentheses. In the denominator, we are going to put this in the first parentheses and put this in the second parentheses. So basically, we are using this value minus this value and as the numerator, and use this value minus this value as the denominator. Okay. Numerator 5 minus 4 is 1. Denominator 92 minus 3. You lose $2 at the first game and use another $3 second game, so you end up with losing $5. The slope is -1/5. Either way, you can try both methods to see which one you like better. Everybody is different, right? I feel I like this method, maybe this method is not yours. You have to really practice in order to know that. Let's go back number 19. What are we looking for here? We got a slope found. And we need to find the equation in the slope intercept form. So we have, so the equation can be written as y equals mx plus b. We found m already, right? We're gonna plug in m equals -1/5x plus b. And the rest of the work is to find the value of b. How do we find the value of b? I have a question here. How do we find the value of b with the given information? Refer to the previous two questions we have done. How do we find the b in this question? How do we find the b in this question? We have two given points, right? Yeah, you can type your answer. You can type your answer in the chat. Plugging in slope. We are already plugging in slope. You mean plugging in a given point? I believe you mean plugging in a given point. We have two given points. One is -2, the other is 3, 4. I'm going to use -2, I'm going to use this point. Either one would be fine, would work, but I'm going to use -2, since -5 is on the line. The pair -2, is a solution of the equation. So -2, 5 should satisfy the equation. Satisfy the equation means if we plug in x equals -2, y equals 5, we should have a true statement, right? I changed my mind. I want to plug in 3, 4. It really doesn't matter. The reason I changed to 3, 4 because I don't want to handle negative sign. I'm going to change 3, 4. 3, 4. 3, 4. The equation is y equals -1/5x plus b. We're going to plug in x equals 3, y equals 4. So x equals 3, y equals 4. Now in this equation, b is the only unknown. This is something from chapter 2. We should be able to solve this equation for b. Left side of the equation, we have 4. Right side, we have a -3/5 plus b. If we move -3/5 from right to the left, we have 4 plus 3/5. b equals 4 plus 3/5. And we can switch the sides. We have b equals 4 plus 3/5. And it could be a mixed number 4 3/5. That's good enough. Or we can convert it to improper fraction. 4 plus 3/5. 4 is 20/5 plus 3/5 equals 23/5. So b equals 23/5. Therefore, the equation in the slope-intercept form is y equals -1/5x plus 23/5. And this question is complete. Solution is complete. If I were you and I had this question on the test and I got my solution like this, what I would do is I would double check by plugging in -2, 5 and 3, 4. If -2, 5 and 3, 4 both pairs satisfy the equation, that means my equation is the correct solution, is the correct form. All right, so this question also has 2 parts. The first part is to use the 2 given points to find the slope. The second part is to find the value of b. Let me know if you have any questions. Yeah, those a few questions are pretty long. Do you have any questions? If not, let's move to the last section of this chapter. In this chapter, we mainly deal with linear equations in two variables. Let's see any question. Definitely long, a lot to remember. Yeah. It is long, but it only has two parts. Since we are looking for the equation in the slope-intercept form, first part we find slope. Second part we find b, value of b. Yeah, two parts. Kind of like two questions in one, right? Okay, so we are going to continue. The last section of this chapter is about the linear inequality in two variables. This chapter so far, we have been dealing with linear equations in two variables, right? You're gonna remember what is a linear equation in two variables. It looks like this: ax plus by equals c. That's a linear equation in two variables. And the last section of this chapter is linear inequalities in two variables. Only one word different. This is an equation. This is inequality. And our task here, the last section, is we need to understand what is a linear inequality in two variables, and what is the solution set look like for a linear inequality in two variables, and how do we graph the solution set in a rectangular coordinate system. And since the name-wise, the two concepts are so close, right? Very similar, very close, not similar. Only one word different, and the two concepts also closely related. Not just the name, very similar. They are actually very closely related. And let me give you what is a linear inequality. Let me give you the definition for a linear inequality in two variables. Number 20. You see this inequality: 2x minus 3y is less than 12. Firstly, inequality. It must have one of the following four inequality symbol, either this, or this, or this, or this, right? We have a strictly less than. So this is an inequality. And how do I know this inequality is a linear inequality in two variables? This is what we do, okay? We are going to remove the inequality symbol and change it to equal sign. And then we are going to create an equation. Yeah, we're going to copy the left side 2x minus 3y, and then copy the right side 12. Look at the red equation. We got this equation by changing the inequality symbol to equal sign. Of course, we don't have an inequality anymore. We have an equation. And this equation is very closely related to the inequality. Everything is the same, only the symbol is different. This is the inequality, this is the equation. And look at this equation. Is this equation a linear equation in two variables? In other words, is this equation a straight line in a rectangular coordinate system? Let me repeat what we have done, okay? Okay, so you might have your answer. Yes, thank you, Amanda. It is in a standard form, right? It is exactly in a standard form. Ax plus by equals c. Yeah, it is a linear equation in two variables. It's a straight line. And in fact, this red straight line, is the boundary line of the solution set of 2x minus 3y less than 12. A lot of information here. First thing, what is a linear inequality in two variables? How do we know a given inequality is a linear inequality in two variables? It's very easy to check. You remove the inequality symbol and replace it with an equal sign. If you get a straight line, then the original given inequality is a linear inequality in two variables. And the straight line you got is, you know what, the boundary line. It's not something else unrelated. It's closely related to the solution set of the inequality. And the equation we just got is the boundary line of the solution set of the inequality. We can also understand this as a linear inequality in two variables is an inequality whose solution set whose boundary, sorry, let me reword it. A linear inequality in two variables is an inequality whose solution set has a boundary as a line. Is a solution set has a boundary, right? And the boundary is a straight line. If there's a solution, if the solution set of an inequality is a region in the rectangular coordinate system, with the boundary of the region is straight line, then the given original inequality must be a linear inequality in two variables. Well, anyway, in this chapter, when you take the test, the coming test exam 2, about chapter 3, and you see two variables in the inequality, and that is going to be a linear inequality in two variables. Also, you have to get the equation anyway, because we are going to draw the boundary line of the solution set as the first part of the solution. Let's see, how do we graph? Part 1, we're going to graph part 1 or step 1. Graph the boundary line. Graph the boundary line. The boundary line is in the standard form, 2x minus 3y equals 12. Since it's in the standard form, I'm going to use the intercepts to graph it. Two intercepts, x-intercept and y-intercept. I'm going to show you how convenient to find x-intercept and y-intercept if the straight line is in the standard form. To find the x-intercept, we make y be 0. We make y be 0. To find x-intercept, we make y be 0. Make y be 0 means we are going to remove let me do this. That means we are going to remove this part. Make y be 0, we're going to remove this part, right? Make y be 0, we remove that part. Then what is x? Look at this equation. What happened to this equation? The equation was 2x minus 3y equals 12. Now we're going to make y be 0 in order to find the x-intercept. Make y be 0 means we're going to make this part disappear. And you are looking at the 2x equals 12. If twice of x equals 12, then x equals 6. Awesome. Perfect. X equals 6. So 6, 0 is the x-intercept. Very convenient, right? And now let's see, how do we find a y-intercept? To find a y-intercept, we make x be 0. X be 0. So the first component is 0. And what about the value of y? Make x be 0 means we're going to make this part disappear. Then now you're looking at negative 3y equals 12. If negative 3y equals 12, y is gonna be negative 4. Perfect. Very good. Negative 4. And that's how do we find x-intercept and y-intercept for the boundary line. It's very convenient if the line is in the standard form. Finding x-intercept and y-intercept very convenient. Let's plot the 2 points, 6, 0 and 0, negative 4. 6, 0 is on the x-axis. This is the orange. 6 units to the right. 1, 2, 3, 1, 2, 3, right here. Okay. Y-intercept is 0, negative 4. From the orange, we go down 4 units. 4 units right here. And then let's draw the line. But before we draw the line, we have to consider one thing. Okay, let me write it down. If the original inequality symbol is this or this, we draw the boundary dashed line. Yeah, we draw the boundary as a dashed line. We draw the boundary dashed. If the original, the thing I'm writing in red, that those are the rules we need to follow. If the original inequality symbol is bigger than or equal to or less than or equal to with the bar underneath, then draw the boundary solid as a solid line. Okay, so this is the rule. We are going to draw the boundary line, right? The boundary line is 2x minus 3y equals 12, this red equation. We just found their x-intercept and y-intercept, the 2 black points, and we are going to connect the 2 black points to draw the line. But before we draw the line, we have to consider, are we going to draw the straight line as a dashed straight line or a solid straight line? Very important, very important. I give you the rule. Depends on the original inequality symbol. I'm going to highlight that as yellow. The original given inequality symbol is strictly less than. So are we going to draw dashed? Very good. Thank you, Jill. Exactly. Let me explain why, but let me firstly draw the line as dashed. I'm going to use the blue color. Let me see. How do I ruler? Can I do this? No. I'll just hand draw it. Connect them and draw a dashed line. Since it's a straight line, I must draw the 2 arrowhead to indicate that's a straight line going to both directions indefinitely, and then the boundary line passing through the 2 given points. The reason is dashed is because we want to indicate the points on the line are not solutions. The points on the boundary line, they do not belong to the solution set. Okay, they do not belong to the solution set. The pair, order number pair satisfy the boundary line. They do not satisfy the inequality because the inequality is strictly less than. For example, let's try 6, 0. For example, 6, 0. 6, 0 is on the boundary, right? This point. 6, 0 is on the boundary. I'm going to show you why it does not satisfy the inequality by plugging in. Let's plug in. Let's plug in x equals 6, y equals 0 into the inequality. So we have 2 times 6 minus 3 times 0 less than 12. And we have 2 times 6 is 12. Then 3 times 0 is 0. We have 12 less than 12. 12 less than 12 is a false statement. 12 is not less than 12. It's a false statement. So I just shown you the points on the boundary line. They satisfy the equation, but they do not satisfy this inequality. That's why we have to draw the boundary line dashed to indicate that fact, to indicate the points on the boundary do not belong to the solutions. So that's the first part. Okay, we're not done yet. Part 1, we have 2 parts. Our goal here is to graph the solution set for this inequality. And we have success because we already have the boundary, right? We know that this straight line is the boundary line of the region that represents the solution set of the inequality. And this straight line in the rectangular corner system divides the whole system into 2 parts. One is this half plane, the other is this half plane, right? Yeah, since this straight line is the boundary line, one of the half plane is gonna be the solution set of the inequality. And second part, we are going to figure out which part, which half plane is the solution set. So part 2, step 2, is to find a testing point. Use 0, 0 if 0, 0 is not on the boundary. Let me show you how. So we are going to use 0, 0. Where is 0, 0? This is 0, 0. We are going to see if 0, 0 satisfies the inequality. Plugging in x equals 0, y equals 0 into the inequality. The inequality is 2x minus 3y less than 12. 2x minus 3y is less than 12. By the way, in part 2, in the second step, we do not use the equation anymore. Once we have the boundary line graphed, we're done with the equation. You have to go back the inequality. We do not use the equation anymore. Has nothing to do with the equation, the second part. The inequality. So let's plug in x equals 0, y equals 0. Why do we use 0, 0 as a testing point? Because it's so convenient. We plug in x equals 0, we plug in y equals 0, and the left side simply is just 0, right? And we have 0 is less than 12. Is that true or a false statement? It's a true statement. That means 0, 0 is a solution of the original inequality. Means 0, 0 supposed to be in the solution set in a region that represents the solution set. So that's the reason we are going to highlight the region above the boundary line. We're going to highlight the region above the boundary line. And that highlight the region, shaded region, is the solution set. Okay, the shaded region is the solution set. The shaded region is the whole region in the rectangular coordinate system above the boundary line. It's not a triangle. Okay, it seems like a triangle is because our computer is only this big. The rectangular coordinate system has no boundary. So the whole plane, all the points above the boundary line do not include the points on the boundary because it's dashed. All those points, they make the shaded region, and that region represent the solution set. All the points in the region, they are solutions of the inequality. And at this point, we are done with this question. It's a pretty long process, right? Let me summarize in case you are actually get lost in the middle. I wrote the steps in red. How do we graph the solution set of a linear inequality in two variables? Firstly, we need to find the boundary line of the inequality. How do we find the boundary line? Very simple. We just need to remove the inequality symbol, the yellow one. We're looking at the yellow part. We only need to remove the yellow symbol and replace it with the equal sign. And then we would have the boundary line. And we're going to graph the boundary line. In this case, we use the intercepts, graph the boundary line. And the boundary line could be solid, could be dashed, depends on the original inequality symbol. If the original inequality symbol without the equality, you're going to draw the boundary line dashed. If the original inequality symbol include the equality, like less than or equal to or bigger than or equal to, then you are going to draw the boundary line as a solid straight line. So that's the first part. Second part, we need to determine which side of the line is the region that represents the solution set of the inequality. We use the testing point method. The method is not unique. The method I use the testing point. I always use the 0, 0 as long as 0, 0 is not on the boundary, because it's so convenient when you're plugging in. When you're plugging in 0, 0, knowing, remember you plug 0, 0 into the original inequality. We are done with the equation. Don't use the equation anymore. You are doing the inequality. Plug x equals 0, y equals 0 into the original inequality. If you got a true statement, that means the origin is a solution. If you got a false statement, that means the origin is not a solution. In this case, the origin is a solution. That's the reason we shade the region above the boundary line that includes the testing point 0, 0. In the case the testing point is not a solution, we are going to shade the region of the other side, the opposite side, the other side of the boundary line. Do you have any questions? Am I clear about the whole process? Seems a lot because I like to elaborate a lot the first time when we do the problem. That's why some students, if they are not very patient enough, they get lost quickly. Are we still doing the same question? Yes, we're still doing the same question. I'm just trying to break it down and talk about the details as clear as I can. Did I explain the details clearly? Or do you have any questions? How do you find the line? How do you draw the boundary line? How do you decide which side of the boundary line give you the solution set? Yes, that one's easier. Okay, great. Thank you, Jacob. Perfect. Then we practice one more question about this problem, okay? In this question, the given inequality is y is less than -1/6 times x. We are going to graph the solution set of y is less than. You know what? I'm going to change it. Less than or equal to, okay? Just change it to less than or equal to -1/6x. What's the first step? What do we do the first thing? How do we get it started? Our goal here is to graph the solution set. In Pearson, they worded the problem as graph the region described by the inequality. Same thing. Rewrite what? Rewrite the inequality symbol as equal sign. The first part is, you're right, we're gonna rewrite the inequality symbol as equal sign. Yeah, change it to equal sign. And what do we get? How do we call that thing? If we change the inequality symbol to equal sign, we get the what of the region described by the inequality? The boundary, right? The boundary. Non-intercept is the boundary. Yeah, boundary line. The first part is to find a boundary line. First step one, is to find a boundary line. Now we are going to change this to equal sign. And we are going to have y equals -1/6 times x. That equation is the boundary line of the region. The region we are looking for. The region is described by the inequality. Okay, how do we graph the boundary line? How do we graph y equals -1/6x? Okay, let me show you how do I graph it. Use a different method, okay? In this case, I'm going to use slope. I'm going to use slope and intercept to graph it. I'm going to write the equation in the slope-intercept form. Y equals -1/6x plus 0. Am I right? Is the slope-intercept form is y equals -1/6x plus 0? X-intercept and y-intercept. Jacob, in this case, actually it doesn't work because this straight line passing through the origin, both of the x-intercept and the y-intercept are gonna be 0, 0. Means if we only consider intercepts, we would only find one point from the line. One point does not determine a line. So I'm going to use this question to demonstrate how do we graph a line by using slope and intercept. Firstly, do you agree the equation can be written as y equals -1/6x plus 0? And then compare that with the slope-intercept form and tell me what is the slope and what is the y-intercept. What's the slope? What's the y-intercept? What's the slope? Huh? Look at here. What's the slope? And what's the y-intercept? Slope is -1/6. Very good. Thank you, Amanda. And the y-intercept is 0, comma what? 0, 0, right? Do you agree, Jill? Is the slope equals -1/6? Slope is the coefficient of x, right? Very good. And what's the y-intercept? Guys, you need to find the y-intercept for me. What's the value of b? What's the value of b? Yeah, exactly. Thank you. Thank you, Amanda. Thank you, Bell. Is 0. The y-intercept is 0, 0. 0, 0. Okay, let me show you how do we use the slope and the y-intercept to graph a straight line. Okay, so firstly, I'm going to plot the y-intercept. The y-intercept is the orange in this case. Not always. In this case, yes. I plot the y-intercept. It is a point on the line. And then I'm going to use the slope. How am I going to use the slope? The slope is a -1/6. I'm able to write this fraction as either -1/6 or 1/6. Right? Yeah, I'm able to write this fraction -1/6 as either -1/6 or 1/6. And it is rise over run. And I want you to pick either this one or this one. It really doesn't matter, by the way. I can pick for you. How about we pick this one. 1/96 equals rise over run. And that gives us numerator rise is 1, run is -6. That's how do we find the rise and the run from the slope. Write the slope as the quotient of two integers. If it's negative, you can place negative sign either on the top or on the bottom, doesn't matter. Suppose we use this format. The slope is 1/6. Then that means rise is 1, run is -6. Okay, so remember that, okay? Remember, rise is 1, run is -6. From the y-intercept 0, rise is 1, so I'm going to go up 1 unit. Rise 1, go up 1 unit. Run is -6, so run is -6. We are going to the left 6 units. 1, 2, 3, 4, 5, 6. And we plot the second point. Okay? From the origin, we go up 1 unit and go to the left 6 units. We use rise and run to plot, to locate the second point. Okay, now we have 2 points. We have 2 points. We are going to connect the 2 points to draw the boundary. Question: are we going to draw the boundary solid or dashed? Are we going to draw the solid? Thank you, Jill. I have not asked the question. You already typed it. Awesome. Very good. Thank you, Jacob. Solid line, because the inequality symbol is less than or equal to, right? Very good. The reason we draw it as solid is because I'm going to change the green color this time. Green color. Is because we want to indicate we draw the boundary line solid because we want to indicate that the point on the boundary are solutions. I wish I had a ruler. Yeah, you know this is supposed to be a straight line, okay? This is the boundary. I draw the solid. That's the first part. We got the first part done. What's the second part? What do we do now? Again, our goal is to find a region, find the region that represents the solution set of the inequality. All the points in the region are the solutions of the inequality. The region includes all the solutions of the inequality. And we know it's going to be either the region above the boundary or the region below the boundary, right? How are we going to decide on that? How are we going to determine? How do we determine that? How do we do the second part? In the previous question, I described the second step is to find a testing point, right? Always use 0, 0 if 0, 0 is not on the boundary. Technically, any point in a rectangular coordinate system can be used as the testing point as long as it's not on the boundary. Any point would be fine, as long as it's not on the boundary. But you want to use a point that is easy to calculate. You don't want to use fractions if you hate fractions, or you don't want to use decimals to make your job more complicated, right? The reason I use 0, 0 in previous question is because 0, 0 is the most convenient. However, in this case, we cannot use 0, 0. Yeah, we cannot use 0, 0 as the testing point anymore because 0, 0 is on the boundary. It's like it's on the fence. I'm on the fence. I don't know if I go to the right or I go to the left. Then, of course, you are not gonna use that point on the fence to determine which side, right? You have to pick a point not on the boundary line. I'm going to use 1, 1. Okay, change the color. Or I can do this. Put a cross here. I'm going to use 1, 1. The reason is because 1, 1 is also pretty straightforward, pretty convenient. Second step, we are going to plug. We're going to choose 1, 1 as the testing point. We're going to plug x equals 1, y equals 1 into the original inequality. One common mistake is you spend so much energy to finally get a graph of the boundary line, and you kind of like attach on the equation and forget the inequality is the main thing. So after you have the boundary done, do not use the equation any longer. When you're plugging in the testing point, you're plugging in the testing point into the original inequality, which is y is less than or equal to y is less than or equal to negative 1 over 6x. Okay, so y is 1, x is 1, very convenient. This is 1 less than or equal to negative 1 over 6 times 1. And we have, I don't have any space. So I'm just right here. 1 is less than or equal to negative 1 over 6. It's pretty easy to determine if the statement true or false. The inequality on the bottom, is that a true or false statement? Is 1 less than negative 1 over 6? Yes or no? Is 1 less than negative 1 over 6? Of course, it's a false, right? It's a false statement. Yeah, you are right. You are correct. It's false. That means that is 1, 1 is not a solution. That means 1, 1 are not supposed to be in the region you are graphing. So I'm going to graph the region as green this time because I used the blue already. Use green. You help me to determine. Am I supposed to shade this region or shade this region? Below or above? This is below. This is above. You tell me, are we gonna shade the region below or above? Below, bottom, correct, very good. The region without the testing point, because testing point does not satisfy. We're gonna shade the region below. Okay, all the points below the boundary line, they are solutions of the inequality. I choose a questions very different. A lot of details are different from the first question. This question we have dashed line. You're gonna know why we draw the boundary dashed. And this second question we have a solid line. What's the reason? And the first question we use the intercepts to draw the line. And this question we use the slope and the intercept to draw the line. Method-wise are different. Also, this question we use the 0, 0 origin to be the testing point. And this question 0, 0 doesn't work. And how do we find a different testing point? And with those two questions understood, you should be okay for this topic. Any questions? You want to try one in Pearson? Let's find a question in Pearson. Let's see. I'll log in again. Sorry, let me restart the page. Assignments, chapter 3, homework. Let's see if this is about inequality. Nope. This one. That's a question. Let me see. Can I find something else? Okay, I'm gonna do this one. Any questions? Let's see. I was wonder why the last one wasn't a dotted line. It was just it was less than or equal to. She changed it to a line under the. Yeah, I changed it. Thank you, Jill. It wasn't. It is less than, strictly less than. I just want to make a different, make a question that different from the first question. So I changed the inequality symbol to less than or equal to right here. I changed it to less than or equal to. Oh, okay. Let's look at Pearson. What's the question I got just now? Yeah, this one. Let's maximize. Let's see this question. Graph the region described by the inequality. You tell me how to do it. What's the first step? What's the first step? The inequality is x is bigger than or equal to -4. It doesn't have a y. Doesn't matter. It doesn't have a y. What does that mean? The inequality missing variable y. What does it mean? Knowing this is, you are gonna graph it in a rectangular coordinate system. That means you are looking at this inequality in a two-dimensional space. What's the first thing we need to do? Y is 0. Coefficient of y is 0. Y is not just 0. Y could be any value. Coefficient of y is 0. Coefficient of y is 0. So what's the first thing we need to do? How do we deal with this inequality symbol? What's the boundary line? What does the boundary line supposed to look like in this case?
Change it to an equal sign.
Awesome. It's going to be x equals -4. All right, write it down on your scratch paper. X equals -4. What kind of line that is? X equals -4. What kind of straight line that is? X equals -4. But cancel.
It's going to be a vertical line, right?
Yeah, exactly. Vertical line. You just draw a vertical line like that. You see that? I draw a solid, am I right? Did I do the right thing? I draw the line solid. Yeah, very good. And then what I do? What should I do? So this vertical straight line is the boundary. We have a region to the right and we have a region to the left. Which region is the region representing the solution set of the inequality? And let's see what I do right now. I should do this, right? And pour the color. And where should I pour the color? Should I pour to the right or should I pour to the left? To the right. What's the reason? It's because I use the 0, 0 as a testing point, right? Use the 0, 0 very convenient. Plugging in x equals 0, y equals 0 into the original inequality. So you have 0 is bigger than or equal to -4. 0 is bigger than or equal to -4. So we got a true statement. That means the origin is right here. The origin is to the right side of the boundary. The origin is the solution. So that's right. I shade the region to the right of the boundary. And then check answer. It's correct. All right, that's something we do. And you can do this yourself. Draw the line and then decide which side. Okay, so this is the last section of this chapter. Let me look at the time. We have 20 more minutes. How about we do some exercise? Let's look at this question. Write an equation of the line in the figure below. The equation of the line is simplify your answer. Type your answer in slope-intercept form. Use integers or fractions for any numbers in the equation. Were we gonna go over any of the exam 1 questions? If you'd like, yes, we could. We could. Let me go to, but I'm not sure if I go to my exam 1, it's the same questions that you saw on your exam. I'm not sure they are the same. They're probably not. Assignments, exam 1. Do you still want to look at it? If that's easier, I could check my test and bring some on Wednesday. I could check my test and bring some. Bring some on Wednesday. Oh yeah, check your answer. Check your exam, and then if you have any questions, and you ask on Wednesday. That's a good idea. So I'm gonna go to. How about let's do the quiz of chapter 3. Quiz 3 is supposed to be the chapter 3 questions. We have 25 of them. Okay, no problem. Let's see this one. 25 questions. Can we get it done within 20 minutes? Let's see. For the equation, answer part A and part B. Part A, state the x and y intercepts. Where's the equation? For the here, sorry. So for the x-intercept, type a pair x-intercept, so y value is 0. So I'm going to put a 0 here first. And x value, yeah, we make a y be 0 here. X value is going to be -4. Because if y is 0, the left side is 0. 0 equals 4 plus x. X has to be -4 in order for that to be true. So that's the x-intercept. Any questions? You don't have to do this. I just don't have a scratch paper to show you. The y-intercept, you click here and put a 0 in the first component as the first component because y-intercept has a 0 as x. And what is y value? If x is 0, you remove this part. You see my arrow, the green arrow cover x. X is 0, so this part disappears. And you have 16y equals 4. If 16y equals 4, what is y? It's going to be 4 over 16, right? What is 4 over 16? Oh, you are able to use a calculator. So 4 over 16 is 1 over 4, it's a quarter. You have to simplify. I believe you have to simplify your answer. 1 over 4. And those two pairs are the intercepts. 1 over 4, right? Not just the 4. 1 over 4. Yeah. Part B. Use the intercepts. Draw the line. Okay? 94, 0 and 0, a quarter. 94, 0. 94, 0. I have a problem to see those. Might be. I have a problem to see those so thin things, so small. Is that 94, 0? And 0, 1 a quarter. And that is 1. How am I supposed to find a quarter? It is too small. A quarter, this is 1, 2, 3, 4. Should be here. 1, 2, 3. Let's give it a try. 1, this is a 0. 1, 2, 3. This is a 1, 1, 2, 3, 2. 0.25, yeah, a quarter. If I get this question wrong because I don't see it well, it's too tiny. Next. Graph the region described by the inequality. Similar with the question we have earlier. So firstly, I'm going to graph the boundary line. The boundary line is going to be solid. Think about y is going to be solid. And the boundary line equation is going to be x equals 3. So from the orange, I go to the right 3 units and draw a vertical straight line. Vertical straight line. And I'm going to consider using the origin as the testing point. I plug in x equals 0, I got a true statement because 0 is less than or equal to 3. That means the origin is a solution. So I'm going to pour the region to the left side. That's my solution. Do you agree? It really doesn't spend too much time once you understand it. Once you understand it, it really just very quickly. You can get it done very quickly. You actually should be happy if you have a vertical or horizontal boundary line because it's easier to graph. Next. The equation of the line. Simplify your answer. Type your answer in slope-intercept form. Use integers or fractions for any numbers in the equation. Write an equation of the line in the figure below. Okay. Since we are doing slope-intercept form, you're going to tell me what is the slope and what's the y-intercept. What's the slope? Is the slope going to be positive or going to be negative? Remember, slope is rise over run. What's the rise? What's the run? I see the two red points. I think the rise is gonna be 2 down, 2 units down. So rise is 2. And what is the run? Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 7. Hold on. Let me do it again. 1, 2, 3, 4, 5, 6, 7. 7. So the run is 7. So the slope is negative 2 over 7. Slope is negative 2 over 7. It has to be negative. And the y-intercept, since it's passing through the origin, the intercept is going to be 0, plus 0. Do you agree my solution? Negative, yeah. And that's it. Find the slope of the straight line that passes through the given pair of points. Okay? Let's see what's the slope. The slope is going to be rise over run. The rise, I'm going to use negative 8 to minus negative 4. Negative a minus negative 4, you should have that on your scratch paper. Negative a minus negative 4 is the same with negative a plus 4. So it's going to be negative 4. Right? Negative 4. That's the rise. I use negative 8 minus negative 4. Negative 8, negative 4. Think about on the y-axis, the distance between negative 4 and negative 8 has to be 4, right? So negative 8 minus negative 4 is negative 4. And the denominator, I use 3 minus 7 over 4. I have to, let's do the scratch paper. Three minus, what is it? 3 minus 7 over 4. Three is 12 over 4. You should do the same thing on your scratch paper. 12 over 4 minus 3 over 4. Sorry, 12 over 4 minus 7 over 4 equals 5 over 4. 5 over 4. So denominator is going to be 5 over 4. So numerator is negative 4. Denominator is 5 over 4. So this actually is negative 4 divided by 5 over 4. And keep changing flip times 4 over 5. So we have negative 16 over 5. Negative 16 over 5. This actually is a good question. Negative 16 over 5. You know what? I'm going to, let me type this. Negative 16 over 5. I do not recommend this question using the graphical method because it has a fraction. Next. Find an equation of the line that has the given slope and passing through the given point. The equation of the line is, type your answer in the slope-intercept form. Slope-intercept form, y equals mx plus b. M is given, negative 3x plus b. And what's the value of b? We have to figure it out, right? We have to figure it out. 3,7. The given point is 3,7. The straight line is y equals 93x plus b. We're plugging in x equals 3, y equals 7. 7 is here. 3 is here. Plus b is here. 7 equals 93 times 3 is 99 plus b. And what's the value of b? What's the value of b, guys? Do you have a 16? Yeah, perfect. So b is 16. That's something you need to write on your scratch paper. 16. Since you only have one attempt for your test, you have to make sure everything you type in the cell is correct and follow the requirement. You have to read everything in the parentheses. Those instructions are very important. Next. Find an equation of the line, write the equation in the standard form. Well, this time is the standard form, okay? Okay, so parallel to that, I'm going to process this problem on my scratch paper. We're looking for a straight line in the standard form. And the line must passing through 4, 1 and parallel to the given straight line. Let's find the slope for the given straight line. What's the slope of hx minus y equals 5? Can you help me to get that? Can you help me to find the slope for this straight line? What is the slope of hx minus y equals 5? Eight. Awesome. It is 8. Positive. So the equation is going to be y equals 8x plus b. And we're going to plug in 4, 1. Y is 1. X is 4. Tell me, please, what is b? 8 times 4 is 32. Do you have negative 31? Awesome. So the equation is going to be y equals 8x minus 31. However, you do not enter this in the cell. You are going to enter 8x minus y equals 31 because that's the standard form. Standard form looks like this: a times x plus b times y equals c. In a standard form, both the two variables are on the left side. The constant term is on the right side by itself. So what I have done, look at the slope-intercept form. We have 3 terms. What I have done is I move the y over, so y become negative y. So we have hx minus y on the right, and I move negative 31 over, I have positive 31 on the left. And then I switch the sides. Left side and the right side, switch them, and I have 8x minus y equals 31. So that's what we need to enter in the cell. 8x minus y equals 31. You must read the information in the parentheses. You use integers or fractions for any numbers in the equation. Simplify your answer. Find the equation, write the equation in the standard form. You have to write it in the standard form. What's the standard form? 8x minus y. 8x minus y equals 31. 8x minus y equals 31. Find the missing coordinates to complete the following ordered pair solutions to the given linear equation. So the given linear equation is y plus 7x plus 8. Missing y, the first pair missing y value. Then we just need to plug in x, right? Plug in x equals 91 here. 7 times 91 is 97. Tell me what's the y value? $15? Yeah, correct. 15. Awesome. And the second pair is also missing y value. The given x value is 5, so we're going to plug in x equals 5 here. 7 times 5 is 35. Please tell me what's the corresponding y value when x equals 5. It's going to be negative, right? Exactly. Thank you, Amanda. Negative 27. Very good. Negative 27. Negative 27. Perfect. This question is to find the slope and the y-intercept. What's the slope? Very straightforward. If you this type of question, you probably will see this type of question in the test. And if you lose the point on this type of question, I don't know what to say, because it's just a definition of the slope-intercept form. There's really nothing difficult. Very straightforward. What's the slope? Negative 2/9. Perfect. What's the y-intercept? Read the information in the parentheses. Type an ordered pair. Simplify your answer. Y-intercept is going to be 0, 5/9. 5/8, right? 5/8. Very straightforward. Please do not enter just the 5/8. You will get it wrong. You must type under the pair. Simplify your answer. 0, 5/8. Awesome. Thank you, Amanda. Next. Graph the region described by the inequality. All right, so what's the boundary line? The boundary line is going to be y equals 8x. Write that on your scratch paper. The boundary is going to be y equals 8x. Slope is going to be 8. 8 is 8/1. Rise over run. And the y-intercept is going to be 0, 0, because when x is 0, y is 0, right? 8/1. So let me graph the line. It's gonna pass in the origin. Rise over run is 8/1, so rise 8, 6, 7, 8. No, that's not what I want. Do it again. This is the origin. Go up 8, go over 1, rise over run. 6, 7, 8. And that's the boundary. Did I draw the boundary? I draw the boundary solid, right? It's correct because it's bigger than or equal to. And which side should I shade? Which side should I shade? This time I would try a testing point, let's say 3, 0. 3, 0. If you plugging in 3, 0 into the original inequality, would you get a true or false statement? 3, 0, you would get a false statement. Because when x equals 3, it's 24 on the right side, left side is 0. 0 is bigger than or equal to 8x. 0 is bigger than or equal to 24 is false. That means 3, 0 is not a solution. We have to shift the region the other side. Alright guys, let's submit. Let's see if we get what we done correctly. Yep, the question we went over, the question we did, all correct. Now we're gonna stop here, and on Wednesday we are going to start chapter 5. On Wednesday, let's see the syllabus. Today is 25th. We finished the chapter. And on Wednesday, we're going to start chapter 5, the first 2 sections. All right, guys. Thank you guys for coming. I'll see you on Wednesday. Have a good night. Bye-bye. Good night.